is there? Double integration method is there. So we need not focus much on the double integration method because it will take more time. Okay, sir. You'll see first one, direct formula. So before going to that, what is this equation? Euler's bending equation. Correct? Euler's bending equation. Sir, what is this y? Distance between calculation point and neutral axis in the cross section. Then r, what is r? Sir, radius of curvature. 1 by r is curvature. Okay, very good. R is radius of curvature, 1 by r is curvature. Okay. Sir, what do you mean by radius of curvature? Imagine there is a simply supported beam, blue color, simply supported beam, right? Central point load. So it is bending. The beam is bending like this. Now we are going to draw a circle such that it is completely seating on the deflection curve. Completely seating on the deflection curve. Correct? Right. The radius of this imaginary circle is nothing but radius of curvature. Okay. So 1 by r is nothing but curvature. Did you study this formula in the max subject? Did you study this? Anyone? Differential equation chapter. Very famous example. So what is the degree? What is the order? That is the question. Okay. So for that, this is the good example. One of the good example. Right? So for finding the order and degree, we are using this example. Right? Actually, this is a equation used for deflection of beams. Right? So this is equal to curvature. That is equal to curvature. Okay. Sir, what is this y, sir? D square y by dx square. Right? What is this y? This y is different from the original y. Correct? Right. Originally, the first y is nothing but distance between calculation point and neutral axis within the cross section. But here, this y is here. This is a beam, right? This is a beam. This is a deflection, right? So this deflection, maximum deflection, is nothing but delta or y. Okay, right. Okay, sir. So this y is deflection of the beams. Okay. So d square y by dx square divided by 1 plus dy by dx square whole power 3 by 2. Sir, what is dy by dx? Sir, y is deflection means what is dy by dx? Slope. Right? Slope. So we are assuming that practically slope is very, very small. Right? So this term is very small. If you square it, again it will be very small. Again, whole power 3 by 2 means it will be almost vanishing. So denominator will become 1. Right? So 1 by r. 1 by r is approximately equal to d square y by dx square, only numerical part. Right? This is the final equation. M by I is equal to sigma b by y is equal to E by r, original, right? So this 1 by r is replaced by d square y by dx square. Right? Sir, in this equation, two y's are available. Both are different y. First y is different. Second y is deflection of the beam. Okay. Okay, sir. Now, this M, right? What is this M, sir? M is a bending moment equation. It is not a single value. Okay. So, for example, we are writing like this. Just modify. M by I is equal to E into d square y by dx square, right? So bring the I to the right hand side. M is equal to EI into d square y by dx square. So this m is not a single value. It is an equation. We have to write. We have to write. What is E? Young's modulus. What is I? Tell me. Answer. What is this I? Tell me what is this I? Correct name. Quick. Everyone can answer, right? Anybody is waiting in the room? No. Right. What is this I? Sir, area moment of inertia of the whole cross section about neutral axis, sir. Okay. What is EI? Tell me at least answer for this. What is E into I? Everyone answer. What is E into I? Quick. So many students are there.
Flexural rigidity.
Flexural rigidity. This is called as flexural rigidity. Okay, very good. Okay, sir. So if the cross section is not changing, it is a constant. Okay, I told this is a equation. How to write the equation? Take this example. Simple case. Cantilever with the full UDL at a particular location X from the free end. What is a M? Bending moment. Sir, small w into X is load. Into X by 2, this distance, X by 2, is a momentum. So minus, downward, right? Minus small w x square by 2. This is a bending moment equation. This is the way we have to write the bending moment equation. Okay? Right. Okay, sir. M is equal to A into d square y by ds x square. Okay. If you are differentiating the M, it means slope of the bending moment diagram is equal to shear force in that location. Okay. Right. Then dv by dx is nothing but rate of loading. So these two are coming under differentiation side. Differentiation side. Then if you are integrating m by ei, if you are integrating m by ei, it means what? Integrating d square y by dx square. What will you get? dy by dx, sir. dy by dx is nothing but slope. So if I integrate m by ei, I will get the slope. Again, if I integrate the slope is what? Dy by dx. If I integrate dy by dx, what I will get? Y. Deflection. Okay. So in order to get deflection, we have to integrate twice. That is why it is called as double integration method. Okay. So it is a long time process, double integration method. Minimum 10 minutes or 15 minutes it will take. Okay. So from the we are traveling two states. One is integration. First integration, slope. Second integration, deflection. First differentiation. Okay. First case, cantilever with a point load at the free end. Standard case. Maximum deflection is equal to capital W L cube by 3 EI. Then cantilever with the full UDL. Maximum deflection is equal to small W L power 4 by 8 EI. Square by 2 EI. ML square by 2 EI. Simply supported beam with the central point load. WL cube by 48 EI. WL cube by 48 EI. Capital W. Right? Simply supported beam with the full UDL. Maximum deflection equal to 5 by 384. 5 by 384. Very famous answer. Into small WL power 4 by EI. Yesterday, We have seen a particular case many times, right? It is asked in the previous years. Sir, this one, sir. Maximum bending moment for the simply supported beam with the full UDL. This asked many times. Yesterday you have solved, right? Okay. So these are the 5 standard cases you must remember the deflection formula. Compulsory. If you want mark, you must by heart this. Okay. Next, moment area method. Moment area method. Deflection formula in the double integration method. Sir, first we have to write the equation, sir. Support reaction. First step, support reaction, right? Support reaction. Second step, bending moment equation. Third step, integrate M. Slope equation, right? Slope equation. Say the slope equation, one C will be there. The slope equation, one C will be there. Right? C means integration constant, C1, right? So how to calculate the C1, sir? By substituting the boundary condition. C1 equal to S. Okay, right. Then again integrate theta. We will get deflection equation with the C2. Right. Again find out the C2. C2. Right? Okay, done, sir. C2. Now what you are getting? Deflection equation only. Deflection equation only. Where this equation is valid, sir? Valid at all point. Valid everywhere. Sir, I don't want the deflection value at everywhere. I want maximum deflection only. If you want maximum deflection, differentiate this. Differentiate this. Okay. Eighth step, dy by dx equal to 0. It means what? Slope equal to 0. In that location, it will not give the deflection value. It will give the x value. X at which theta equal to 0, y equal to y max. Location only it will give. So in that location, find the y value. This is equal to y max. Right? So this is the regular step. Tell me how much time it will take. Tell me how much time it will take to find the maximum deflection. At least. How much time it will take? Approximately. Anyone, you are in the final stage, right? You should judge the time consumption. GATE exam is nothing but strategy. Time calculation, at least prediction of time is must one, right? It's a talent. It's a kind of talent. So at least if you are in full form, minimum 15 minutes it will take. Minimum 15 minutes, sometimes 20 minutes also it will take. Right? But we don't prefer that method. Already I told. Okay, sir. Moment area method. Moment area method very, very, very important for both departments, right? So we are going to see the standard cases only. Draw the bending moment diagram. Sir, this is the bending moment diagram, sir. Regular bending moment diagram. Write the values. Sir, here it will be W into L. Divide by EI. Divided by EI. Okay, right. Sir, if I am dividing the bending moment values by E into I, will the diagram change? No, diagram will not change. Only values will change. Right? Shape of the diagram will not change. Only value will change. Okay, done. So this is not a bending moment diagram. This is M by EI diagram. M by EI diagram. Right? So notice carefully. First time I will explain fully. Right? Sir, where you want the slope, sir? I want slope here. Why you want to slope in that location? Sir, in that location only slope will be maximum. Sir, what do you mean by slope? At every point, you can see the rotation of the point, correct? Can you find the rotation of the point? So the rotation, due to the rotation of the point only, deflection happens, right? The rotation of individual particles is nothing but theta. This theta is nothing but slope, correct? The degrees of freedom, in the degrees of freedom, tell me, what are the degrees of freedom for 2D? Tell me, what are the degrees of freedom for 2D? Tell me, what are the degrees of freedom for 2D? Quick. So don't say my net speed is slow, sir, like that. Type it. You should be dynamic. You cannot say I don't like online classes and all. Wherever the practice is available, you have to do. Ux, Uy, theta is it, correct? Sir, in the engineering mechanics, we studied Ux, sir. Correct? Right. Sir, that is nothing but deformation. Deformation, del L, in the SYM. Correct? Right. Then Uy, you studied, right? Uy. Vertical displacement. Correct? Right. That is nothing but deflection in y direction. Deflection in y direction. Deflection of the beam. Right. Then theta z you studied, right? Theta z. Rotation about z axis. That is nothing but slope. Correct? Right. So fundamental terms are called as ux, uy, theta z. But commercial terms are called as del L, deflection, slope. Correct? Okay, right. Because some students are thinking degrees of freedom will not be involved anywhere in the SOM machine design like that. Everywhere till end theory of failure, right? Degrees of freedom is a hero, right? Okay. Okay, sir. This is the maximum slope point. Right? Right. Sir, where you want deflection? Here only I want deflection, sir. Why? I want maximum deflection. I want maximum deflection. You know the deflection pattern. This is the maximum deflection point. Okay, done. Done, sir. Okay. Now, see here. This is the calculation point. Right? Next, boundary condition. Boundary condition means what? Known values of degrees of freedom. Where the slope is 0, sir, at the fixed end, slope is 0, sir. Where the deflection is 0, where the deflection is 0, at the fixed end, deflection is 0, sir. Correct? Right. Okay, done. Deflection is 0, slope is 0 at the fixed end. Okay. Now come to the M by A diagram. This is the calculation point, right? First calculation, slope. Sir, area of M by EA diagram. Area of M by EA diagram between calculation point and slope is equal to 0 point is nothing but slope. Slope at the calculation point. Right? Sir, what is the formula, sir? Right. Sir, slope is equal to A. Simply I am saying slope is equal to A. A means what? Area, sir. Which area, sir? Which area? Area of M by EA diagram between calculation point and slope equal to 0 point. Correct? What is the area? Of BH, right? Of BH. Of BH. Correct? Of into B into H. Right? So WL square by 2A is a slope, maximum slope for this case, first case. Right? Okay, sir. Slope is ready. Any doubt? Any doubt in the slope equation? Answer, please. Any doubt in the slope equation? Any doubt? Slope is equal to A. A means area of M by EA diagram between the calculation point and slope equal to 0 point. Okay. Second, deflection. Sir, I am saying deflection is equal to A into X bar. A into X bar. Sir, what is this A, sir? Area of M by EA diagram between calculation point and deflection equal to 0 point. Previously, I told slope equal to 0 point, right? Because previously we were calculating the slope. Now I am calculating the deflection. So area of M by EA diagram between calculation point and the slope equal to 0 point. Okay, sir. Where is the calculation point? Here, sir. Where is the slope equal to 0 point? Here. Sir, this area already calculated. Already calculated that area. Tell me. Answer. Yes, sir. Already calculated. Already calculated. Okay. So luckily already calculated. Time saving. Okay, sir. So A into X bar. What is this X bar? Right? X bar is the distance between calculation point and centroid of the selected area. Okay. Distance between calculation point and calculation point, centroid of the selected area. This area. Right. So what will be this distance? 2 by 3 L, sir. Correct? Right. Okay. So already area is calculated. Don't repeat. Okay. Directly write it. WL square by 2EA. X bar is 2 by 3L. Multiply this, you will get WL cube by 3EA. WL cube by 3EA. Correct? Very, very important method. In my experience, most of the students told that, previous year students told that moment area method is helping a lot, sir, in the critical situation. Okay? Right. Next case. Cantilever with the full UDL. You know this bending moment. Name of this diagram, BMD diagram. Parabolic spandrel. Parabolic spandrel. Right? So what is the bending moment value? Small w L square by 2. I don't want a bending moment diagram. I want M by EA diagram. Simply divide by EA. That is enough, right? Don't change any diagram. Only values are changing. Then where is the maximum slope point? This one. Where is the maximum deflection point? This one, sir. Where is the slope equal to 0 point? Here. Deflection equal to 0 point. Here. Correct? Okay. So these things are ready. Now see here. Theta max equal to A. What is the definition for A? Area of M by A diagram between calculation point and slope equal to 0 point. What is the formula for this parabolic spandrel? BH by 3. General formula BH by 3. So 1 by L by 3 into substitute this, you will get small w L cube by 6 EI. Small w L cube by 6 EI. Deflection equal to A into X bar. So same area. X bar distance between calculation point and centroid of the selected area. Right? Right. Centroid of the selected area. Okay. So this one. Area already done. This one. X bar. Substitute this, you will get small w L power 4 by 8EI. Small w L power 4 by 8EI. Okay. Done. Next. Cantilever with a couple at the period. Very simple case. Right. Okay. So BMD will be rectangle. It's a pure bending case, constant bending moment. Simply divide by EA. Okay, sir. M by EA diagram is ready, sir. Sir, this is the maximum slope point, maximum deflection point. This is a 0 slope point, 0 deflection point. Okay, done. First, theta max equal to A. What is A? Area of M by A diagram between calculation point and theta equal to 0 point. Just BH formula, rectangle, right? Rectangle. Okay. What is the formula for rectangle? B into H, right? Substitute. B is length, H is M by EI, right? ML by EI is the slope, maximum slope. Y max equal to A into X bar, same area. X bar is what? Calculation point centered of the selected area. So X bar equal to L by 2. Right? So Y max equal to ML square by 2 EI. ML square by 2 EI. Right? Okay, done. Right. Fourth one, simply supported beam with point load at the center. Central point load. Correct? Sir, this is the BMD. Correct? No doubt in this BMD. Now, generally, what is a deflection curve? Deflection curve will be like this. Correct? This is the original deflection curve. Correct or not? Answer please. This is the original deflection curve. Reply. Original deflection curve. But more, auto more. Right? Area moment is given by him only. Right? Auto more is giving idea. You have to consider the deflection curve like this. Okay. See, it means loads are moving. Which load? Support reactions. This support reactions are moving up. This applied load is stationary. Okay. Just imagination only. Why, sir? Do you know why he is asking us? Sir, before this assumption, imagine I'm writing in the green color. Sir, where is the maximum deflection, sir? Here, Y max, right? Y max. Right? What is the slope in this location? Tell me. What is the slope in this location? Quick answer, at least answer for this. 0. Right? So theta equal to 0. Here, what is the deflection? 0, sir. 0. What is the slope? Maximum, sir. This is the maximum slope. Right? Now see the combination. Sir, 0 deflection is here, 0 slope is here. Maximum slope is here, maximum deflection is here. Right? So both are in the different locations. If you are following his instruction, Otto Moore's instruction, he is our friend, right? Moore circle person is our friend, right? We are following his instruction. Now tell me, for this deflection curve, slope equal to 0, deflection equal to 0 in this location. Slope is maximum, deflection is maximum in this location. Correct or not? Tell me. Yes or no? Yes, sir. Right. So now easy for calculations. Okay, done. So we want the detail between here and here only. Right. Okay. No need of full beam length. Right. Okay. This is a calculation point. This is a slope 0 point. This is a deflection 0 point. Okay. Done. Now what is a slope formula? Slope is equal to A. What do you mean by A? Area of M by EA diagram between calculation point and slope equal to 0 point. Correct? What is this area, sir? Right angle triangle. Correct? Right. Of BH. What is B? What is B for this? Sir, B is L by 2, sir. This is B, right? What is H? Maximum bending moment for this case. WL by 4. Yesterday you told, right? Famous case. WL by 4, right? Divided by EA. So this is the maximum slope formula. Maximum slope. W, capital W L square by 16 EI. Okay. I want maximum deflection. What is the formula? A into X bar. What is the A? Area of M by EI diagram between calculation point and deflection equal to 0 point. Sir, this area, sir. Sir, same area already we calculated. Okay, very good. Lucky available, right? Into X bar. What do you mean by X bar? X bar is nothing but distance between calculation point and centroid of the selected area. What is this length? Sir, 2 by 3 of B. 2 by 3 of B. What is B? L by 2. So 2 by 3 of L by 2 is nothing but L by 3. Data? Okay, sir. If you are multiplying these two, you will get capital W L cube by 48 EI. Capital W L cube by 48 EI. Correct? Right. So for this, it will take long time. But in the one step, in single step, you are getting the slope equation. In the second step, you are getting the deflection equation. Right. Last case, very famous case. Simply supported beam with the full UDL. Very famous one. It is a assumed deflection curve. It's not a original deflection curve. It is assumed deflection curve. Right. Okay. So what is the assumption? So support actions are moving up, load is stationary. Okay. Right. So as per the request, auto more requested us. Okay, right. That is why we are obeying his instruction. Okay, done. I want maximum slope, sir. I want maximum slope is equal to A. What is A? Area of M by EA diagram between calculation point and slope equal to 0 point. Do you remember this formula? What is the area? Sir, 2 by 3 BH, sir. 2 by 3 BH. You studied, right? 2 by 3 BH. Okay, so 2 by 3. B is L by 2. H is H. What is his height? Maximum bending moment. What is the maximum bending moment? Small w L square by 8. Very, very, very famous. In the last two classes, you have seen more than 6, 7 times or around 8 times. This course, it is asked in the previous year mechanical gate exam. So you know the importance. Small w L square by 8. So divided by EA. Sir, what is the formula, sir? Small w L cube by 24 EA, sir. Okay, done. Y max formula, A into X bar. A into X bar. What is A? Same area, sir. Okay. X bar, what is X bar? Sir, X bar is a distance between calculation point and centroid of the selected area. This. What is the formula? According to the original diagram, semi-parabolic area. This is 3 by 8 B. Correct? This is 5 by 8 B. So 5 by 8 into B is what? L by 2. Right? Right. Okay, sir. So 5 by 8 into L by 2 means 5 by 16 L. 5 by 16 L. Right. If you are multiplying this area and this 5 by 16 L, you will get 5 by 384 into small w L power 4 by EA. See, just one step slope equation. Second step, this final deflection equation. So, are you clear about moment area method? Only for standard cases. Don't worry about the non-standard case. They never ask. They know it will consume time. Yes. Okay. Right. So you have some idea, correct? Right. About moment area method. Right. Slope equation one line, deflection equation second line. You can get it. Next, Maxwell-Betti reciprocal theorem. Maxwell-Betti reciprocal theorem. So I have taken simple case. Simple case. What is the case I have taken for study? Sir, cantilever beam with point load at the free end. cantilever beam with point load at free end. Okay. What is the problem, sir? I am marking two locations, I and J. I and J. I is at the middle, J is at the end. Right? Right. Okay. Now I am writing Yij. Okay. Wait and see. Here I am writing Yij equal to Yji. What, sir? Only suffixes are changed. Yes. How to read this first? Deflection. Y means deflection at location I. First suffix. Deflection at location I due to load at location J. Right? Right. So here in this case, what is a load application point? Tell me. What is a load application point? Load application point. I, sir. Calculation point. Deflection calculation point. J, sir. Correct? Right. Now you are clear, right? Okay, very good. Say deflection at I due to J is equal to deflection at J due to I. First suffix calculation point, second suffix loading point. Okay. Okay, sir. Done. Now, first case, apply the load at J, measure the deflection at I. Then apply the same load at I, calculate the deflection at J. Compulsorily, both will be equal. Okay. So we have proved with the help of moment area method. I have proved in the classroom. Okay. Right. If possible, I will show it later. Right. Give me the reminder if you want proof. Right. Already I have done. Don't worry. Okay, sir. So this is proved in the classroom. Moment area method. It is a time consuming, but we have done in the class. Next, strain energy method. Strain energy method. What is strain energy? What is strain energy? Energy stored in the material when it is loaded up to. Come on. Energy stored in the material when it is loaded up to. Interview question. Energy stored in the material when it is loaded up to. So I am completed, right? You have written many exams also. When it is loaded up to proportional limit. Okay, right. So all of our formulas are valid up to proportional limit. Young's modulus, bulk modulus, shear modulus, Poisson's ratio, strain energy, Hooke's law are valid up to proportional limit only. Okay, right. So strain energy is nothing but energy stored in the material when it is loaded up to proportional limit. Strain energy is 100% recoverable energy. Okay, right. Okay, sir. Sir, strain energy formula for uniaxial tensile load. Okay. Half into P into del L, right? Then strain energy formula for torsion. Three formulas, right? Three formulas. Strain energy due to torsion. Half into load into displacement. It means half into T into theta equal to half into K del square. Half K del square equal to half into W into delta. W means what? Axial load applied in the spring. Axial helical spring, right? Axial load applied in the helical spring. What is delta? Deflection of the spring. Can anyone unmute and tell what is the deflection formula for the helical spring? Deflection formula for the helical spring. (64) W R cube N by C D power 4. Correct? Is it correct? Check this. If it is correct, say okay. Otherwise, tell me the correction. Yes, sir. This is correct. 64 WRQ by. So it's the axial deflection of the helical spring, axial load in the helical spring. Right. Done. So strain energy due to axial load, 1 formula. Strain energy due to torsion, 3 formulas. Next, strain energy due to bending, 2 formulas. So strain energy due to bending moment. 2 types of bending moments available. Constant bending moment, varying bending moment. If it is constant, strain energy due to bending moment is equal to m square L by 2EI. M square L by 2EI. What is this length? Yeah, length is nothing but length of the bending moment load. Okay, length of the bending moment load. It is not a length of the beam. Somewhere the bending moment load is applied, right? That length, right? Next, sir, if the bending moment is varying, it means m is a function of x, right? M is a function of x. So integration 0 to L m square dx by 2EI. M square dx by 2EI. Right? This is the formula for strain energy due to varying bending moment. Correct? Right. Okay. So I have taken this standard case, right? Special case. What is the name of this case? What is a special in this case? Tell me. What is a special in this case? What is a special in this case? Diagram? Pure bending, sir. Pure bending in the midspan. Very good. Correct answer. Exact answer. Pure bending in the midspan. Okay. Right. So that example I have taken. It is a 4-point bending. Flexural test. It is a gate exam dimension. These dimensions are given in the gate exam. Okay. So generally we used to say this is A, this is A, total length is L like that. Okay. They are saying L, 2L, L. Like. So this is the bending moment diagram. Already we have done bending moment diagram. So there are 3 regions. Varying bending moments are constant bending moments are again varying bending moments are. Okay. Sir, 1 and 3 are equal. 1 and 3 are equal area. Tell me. Yes. So we can calculate the first area and multiply by 2. That is enough. Okay. So reduce the time consumption. Same diagram I have repeated. Right. For U1 and U3, U1 and U3, just what I am doing, I am calculating ones and multiply by 2. Right. So 2 into, so it is a varying bending moment, sir. This is the original formula. This is the original formula, right? Sir, what is M? Find the M equation here at x distance from the end, right? What will be the moment? Moment equal to W into x. How do you say that it is W? Sir, support reaction, sir. It is a symmetry case. For a symmetry case, simply supported beam, support reactions are equal to total load divided by 2. Total load is W plus W. 2W divided by 2 means W will come. Okay. Done. Okay. So now this 2, bring this 2i outside. So 2 by 2i into integration Wx. You told Wx, right? M square. I want M square. W square x square into dx. So again, W is constant. Take it out. If you integrate this, what I will get? X cube by 3. X cube by 3. Integration limits 0 to L. After substituting 0 to L, what I will get? L cube by 3. Right. So the formula is W square L cube by 3EI. This is the total strain energy due to 1 and 3 only. Okay. Next, strain energy due to 2, force and 2. Constant bending moment. So U2 is equal to constant bending moment, sir. M square L by 2A. It is a general formula, right? What is a M value? M is equal to W into L. This distance L. W into L, right? M square equal to W square L square. What is the length? Length for the second load? Tell me. Length for the second load. Tell me correctly. Length for the second area. Sir, 2L, sir. 2L. Okay. Don't forget this 2L. So M square, okay. L is 2L, right? Divided by 2A. So finally, W square L cube by EA. If you add U1 plus U2 plus U3, I will get 4 by 3 W square L cube by EA. W square L cube by EA. Right? Done. Sir, what is the use of calculating total strain energy, sir? What is the use of calculating strain energy? So far, we are studying the strain energy, right? Strain energy due to axial load, torsion, bending, constant bending moment, variable bending moment. Right? Example, we have included 2 types of bending moment. Best example, pure 4-point bending. Okay, we have calculated total strain energy. Okay, we are going for Castigliano's theorem. Sir, what is Castigliano theorem? Partial derivation of total strain energy due to particular load, any one point load. Okay, there may be n number of point loads, P1, P2, P3, W1, W2, W3, anything. Partial derivation of total strain energy with respect to any particular point load at location I is equal to deflection at location I. Is equal to deflection under the load or deflection at the location I. Sir, this is a statement. Okay, done, sir. Now come to our case. Total strain energy formula is ready. Total strain energy formula. This is the total strain energy formula. Okay. W, if I differentiate with respect to W, what is answer? 8 by 3 WL cube by EA. Right? Sir, where is the deflection, sir? This point and this point. Correct? This deflection or this deflection is nothing but this calculated one, because we are differentiating with respect to this locational point load. Okay. Correct? So is it clear about the Castigliano theorem? Is it clear about Castigliano theorem? Castigliano's theorem. Partial derivation of total strain energy with respect to load at location I is equal to deflection at location I. See the sample diagrams. Whenever you are seeing this kind of diagrams, immediately we have to think about strain energy method, because these are not standard cases. These are not standard cases. Okay. Okay, sir. Done. Here there is a common procedure. Actually, it is not a rule, but in the GET exam answer keys they are following. Right? See here, if I shift the load to this point, okay, right. What are the loads will be coming? Sir, same load, sir, plus one moment, sir. Correct? This, let us say this is A. P into A, this is P. Is it correct? Yes. Similarly, this load, right? If I shift the load here, P, then P into A. Correct? Right. So in the second case, this member, horizontal member, is acting as a cantilever beam. In both cases, this case and this case, horizontal member is acting as a cantilever beam. No doubt, cantilever beam with a point load at the free end. Okay. Then the vertical member, right? We will discuss vertical member separately. Here, in this vertical member, how many loads are acting? Tell me, how many loads are acting? How many loads are acting in the vertical member? How many loads? How many loads are acting? You don't know. This is too much. Two loads. Okay, right. Net is low. Okay, right. So two loads, sir. Okay. Next question to you, sir. This is a vertical member. This is a vertical member. This is a hinge, right? Hinge support. If I am applying the load, vertical load, will this load be transferred to the member, vertical member? No, sir. Now tell me, how many loads are acting in the vertical member? How many loads are acting in the vertical member? Only one. Only one. Moment only. Very good. Okay. So that is correct answer. Moment only is the correct answer. Now come to this case. Here tell me, how many loads are acting in the vertical member? Two. Here we are very clear, right? Two. Both will be acting. Right? But in the GATE exam answer keys, previous year answer keys, right? They are considering only moment. They are not considering this one. Okay. But we don't know the reason, right? We don't know the reason, but we know originality. Originality means both will be acting, no doubt, right? So maybe for reducing the complication, they may assume that this axial point load is neglected, but it is not a strict one. Okay, right. It is an assumed case only. Okay, sir. So in both cases, we are assuming that horizontal member is a cantilever with point load at the free end. Vertical members are subjected to. Now we are assuming, right, based on the previous year keys. Right? We are assuming that vertical members are subjected to how many loads? Only one load. Only one load in both cases. Correct? Right. Sir, we are ready to accept their assumption here. Okay, now here, okay, no doubt. But here we are not ready to accept, but no other way. We want to mark. We will accept the previous experience. Okay, that. See these diagrams. For this kind of diagrams, all are already asked the case. All the diagrams are already asked diagram. Yes, they neglected the effect of axial load in the vertical member. Here, in this case, right? Okay. Right. For these members, already asked members, we have to think about which method? Strain energy method. Strain energy method. particularly these three, strain energy method. This is little bit different, that you will discuss later. Right? Simple method, direct method. This is direct method. These three are involving strain energy method. Right? Direct method na standard case. Yes, for standard case only we are saying the direct formula. For standard cases only. Right? So far, what are the deflection slope formulas we have studied? Sir, direct formula for 5 standard cases, sir. Correct, right? Then moment area method for 5 standard cases. Completed, sir. Slope for the 5 standard cases. Completed, sir. Right. Then reciprocal theorem. Maxwell-Betti reciprocal theorem. Completed, sir. Castiglione theorem. Completed, sir. Okay, right. So the last one is conjugate beam method. Just to know the basics, that's all. Okay, so you cannot do the calculations in the examinations. It is a time consuming one. So length of the conjugate beam is equal to length of the original beam. Okay, M by EA diagram, the diagram of the actual beam will be loading diagram for the conjugate beam. Then actual beam, conjugate beam. See the situations, boundary conditions, fixed end na free end na fixed end. Simply support na simply support at the free end. Simply support in between means not at the free end, means unsupported hinge. Right. Unsupported hinge means simple support. Okay, so these are the comparisons between actual beam and conjugate beam. Right. Okay, so this is enough. Right. I will keep it in the video. In the free time, you can go to this. Right. The conjugate beam, shear force is nothing but slope at the section. Okay, so in the free time, you can go through this slide. Okay, sir. We will stop. Next, we are going for questions. Okay, right. We'll go to the questions. Yesterday we told, right, this question, same question, but instead of deflection, we have studied only bending normal stress. So today we will solve it. Start with a simple question. Right. 4 mark question. 2 plus 2, 4 mark question. First question. Simply supported beam with full UDL. Maximum bending moment M equal to small w L square by 8 equal to small w how much? 120 into L 15. Answer? Quick answer. Answer will be kilonewton meter. Calculate. Do the calculation. Don't to see the yesterday's note. See, if you are not calculating in our class, simply watching in our class, you have to watch in the GET exam also. They will give 3 hours for watching the 65 questions. You can watch very comfortably, right? 3375 kilonewton meter. Okay, right. Next, the value of maximum deflection. Sir, this is a special case, a standard case. Yes, sir. Which case? Tell me. First or second or third or fourth or fifth? Fifth case, right? So for the fifth case, what is a maximum deflection formula? Delta max equal to or y max equal to 5 by 384, right? Into small w L power 4 by EA equal to 5 by 384 into small w. How much? 120 kilonewton meter. Sorry. Yes, 120 kilonewton per meter. Correct? Right. So 120 into 10 power 3 Newton per meter. For mm means or keep in the Newton per meter. Okay, right. Then at last we can convert. Otherwise, we have to substitute here Newton per mm. We should be careful, right? Okay. So I will keep it in meter into 15 power 4 by E 200 gigapascal, 200 into 10 power 9 into I. I dimensions are given, width 120 mm, height 750 mm. 0.12 into 0.75 cube by 12. 12 will go to numerator. Now tell me the answer. Answer will be in meter. Tell me the correct value. Don't make any round off. Very good. Right. So 0.09375. 0.09375 meter. So I want in mm equal to 93.75 mm. Okay. Okay, sir. This is simple question only. Actually, it is simple question, right? Next question. It is a standard case. This is a standard answer. Read the question, then give me the idea. First read the question, give me the idea. Idea. No idea. Wow. What is asked? What is the value of x so that deflection at A is 0? Correct? So shift this load to A. Correct? So first we have to shift the load to this location. Right? Tell me what are the loads will come when we are shifting here? Tell me quick. While shifting the load to this location, what will come? So the same load point P, then one moment, sir. Moment direction, counterclockwise or clockwise, sir? Very good, counterclockwise. Go to the calculation point, see the load, it is creating counterclockwise. What is the moment value? Tell me. M is equal to P into what is the moment? P into L minus X. Very good. Okay, sir, done. P into L minus X. Now we have to shift this load to A. Sir, if I shift this load to A, any change? While shifting the load, point load P to A, no change. Then this is a ring, right? This is a ring couple. The ring can be moved along its own axis, this axis perpendicular to the screen, or it can jump to parallel axis. No change. No change in the side effect. Okay. So same couple will be there, right? Counterclockwise couple. So M is equal to P into L minus X. Okay, right? Okay. Now forget about all the remaining things. Focus only on the top member. Right? Focus only on the top member. What happens? Sir, cantilever with the point load and couple at the free end. M is equal to P into L minus X. Then this is P. It is L. Now we want zero deflection in this point. Zero deflection. It means the downward deflection due to point load should be equal to upward deflection due to couple. This couple is creating upward deflection, right? Downward deflection due to point load should be equal to upward deflection due to couple, right? Downward deflection due to point load is equal to y upward deflection due to couple. Right. Now, what is the formula for downward deflection due to point load at the free end? What is the formula? Anyone? Sir, W L cube by 3A, sir. Correct? Right. So, P L cube by 3A equal to upward deflection due to couple ML square. ML square by 2EI. Correct? ML square by 2A. Did you see similar formula anywhere else? In any other place? Did you see this? Yes, sir. Strain energy. What is the difference? Strain energy due to constant bending moment is m square L. M square L by 2EI. Here, m L square by 2EI. Don't forget. M square L, m L square. Okay. So now substitute the parameters. First, cancel the related items. EI cancelled. EI cancelled. L cube. This. Okay, sir. Done. Remaining things. Right. P by or okay. So P by 3, PL by 3 equal to M is what? P into L minus X by 2. Right? So P cancelled. Right. Now cross multiply 2L equal to 3L minus 3X. Right? Right. So 3X equal to L. X is equal to L by 3. Correct? Is it correct? Yes, sir. This is a standard answer. This is a standard answer. Right. This C-shaped beam. Hereafter, you should not work out in the examination hall. In the examination hall, if you draw all the things and all, time waste. At last, you are going to get this answer only, right? You will not get new answer. Right? Okay. Next question. So option this one. Next question. Read the question carefully. This is also a get question only. Right? Zero, sir. Zero. Standard guess. Last time I told, right? If you want zero deflection here, this should be, this x should be equal to total length, right? Total length by 3, right? Total here total length is 3L. So this is L. So L by 3 only. Total length by 3 only. So cleverly they have given answer 0. Next question. Highly repeated question. This question. Highly repeated question. This model. Right. Read the question carefully. Sir, what is the direction of deflection due to point load P? Direction of deflection. Answer quick. Direction of deflection due to point load P. Down. Down. Direction of deflection due to couple PL by 2. Down. So both deflections should be added. Right? It's a very simple case. Right? So y is equal to y1 plus y2. What is a y1 formula? P L cube by C EI plus M L square by slope is asked. Okay, very good, sir. Slope now, which method you will go? Slope means which method you will go? Slope. Which method we discussed? Sir, moment area method, sir. Moment area method, sir. So bending moment diagram due to couple is perfect rectangle, right? Bending moment diagram due to point load is triangle. Correct? Is it correct? BMD. This is 0. This is PL by 2. This is PL by 2. 0. What is this gap? W into L, right? So PL. This gap is PL. It means this point is equal to PL plus PL by 2. 3 by 2 PL. Right? Okay. So that's all. So what do you want? What do you want? Slope. Where? Sir, at the free end, sir. Now, where is the calculation point? This is a calculation point, right? Calculation point. Where is the slope equal to 0 point? Theta equal to 0 point, y equal to 0 point. Right? Okay, sir. So theta is equal to A. That's all. Finished. Here there are two types of areas. 1, 2. A1 plus A2 equal to A1 plus A2. Right. What is A1? This length is L. Right. A1. P L by 2 into L. A2 half BH. Half into B is how much? L into H is how much? PL. Right. I think we don't want this one. Equal to PL square by 2 plus PL square by 2 equal to PL square. Correct? Right? Okay. So this is for EA. At last divide by EA. So don't introduce EA in between. Don't make it complicated. Correct? So at last divided by EA. Done. Check it. Is there any doubt? Correct? Okay, sir. So if there are two areas, how to use it? A1, A2. So first time we are learning, right? Okay. So far in the deflection, In the deflection, two areas are not asked. Only for the slope, they have asked two areas. Two areas na A1 plus A2. It is easy, right? But for deflection, two areas available means A1 into X1 bar plus A2 into X2 bar. Okay, so don't forget. So I cannot show this example in our get questions because it is not asked so far. Anyway, I will try to show you one situation I discussed in the classroom. Check it SM underscore T naught. Deflection. Yes. I told right. Yij equal to Yji. Okay. Right. So we did in the classroom, one of my online classroom. Right. See here, it is a proof for deflection Ij equal to deflection Ji. And go through it. Quickly go through it. I am not going to speak anything. Just go through it. After going through it, tell me, okay, sir. Then we will go to next slide. Students did not believe it. That's why we did in the classroom. Go through it. Okay, wow. Corresponding area and the corresponding X bar. Here. Clear? Okay. Okay. Done. You can take the screenshot. Can go through in the free time also. Now you are clear, right? Okay. So we are believing Maxwell-Betty reciprocal theorem. Only simple cases will be asked in the examinations. Okay. Right. Next. See this case. Very simple, sir. Very simple, sir. Highest number of repeated question in the strength of material. Highest number of repeated question in the strength of material is this model. Okay, right. Okay, sir. What is the direction of deflection due to point P? Direction of deflection. Direction of deflection due to point load P. Only up or down, right? It is not northeast, southwest. Downwards. Right. Direction of deflection due to couple. That is also downward. Okay, answered. Right. Downward. So both are downward deflection means just add it. Right. So what is a total deflection? Y is equal to y1 plus y2. What is y1? P L cube by 3 EI plus M L square by 2 EI. Right? Right. So direct formula. Sir, in the strain energy method, they used this length in the different way. Sometimes they are saying 2L. Right? The strain energy method, they started the twisting. Trick is available, already involved in the previous years. But in the direct deflection questions, they did not disturb us. This year, it may be asked, right? So they may ask the direct formula, but the length will be 2L, 3L, like that, 4L, like that. Then EI will be 2EI. Here they will say flexural rigidity equal to 2EI. Right? So that kind of twist may be involved, right? But already they involve this kind of information. Length is not L, 2L like that. EA is not EA. It is 2EA, 3EA like that. Do you remember where it is asked? In the mechanical engineering question. Do you remember where it is asked? You don't know. Yes. It is asked for civil. See the twist. Area A, Young's modulus E for most of the trust members. What is the area for the QR? What is the area for the QR? 2A. Correct? So in this way, they may disturb. Already they started disturbing us. For one department, it is started, right? It may be asked at any time for mechanical also. Okay. Right. Okay, sir. Done. So be careful about this length. Okay. Right. Next question. Read the question. Cantilever beam with a flexible rigidity 200 Newton meter square is loaded as shown in the figure. Deflection at the tip. Right. Draw the BMD immediately. Right. What is the maximum bending moment? 500 into 0.05. They are asking deflection in mm. Right. Okay. So 500 into 50. It means 25 into 10 power 3. I am writing only m. Right. 25 into 10 power 3. M is equal to Newton mm. Okay. Done, sir. Right. Sir, I want deflection at the free end tip. So this is the calculation point. This is the calculation point. Right. Sir, where is a zero deflection point? Y is equal to 0. Right. Right. Okay, done. Deflection is equal to A into X bar. Sir, what is the A? Distance between calculation point and Y is equal to 0 point. Full area. Full area is not available, sir. Available area is only this half of the length. Okay, take it. Whatever the available area, take it. So this is 50. So area is equal to 20 half into 50 into 25 into 10 power 3. Area ready? Into X bar. X bar. Right. So this distance. What is this distance? What is this distance? 50 by 3. Right? 50 by 3. What is 50 by 3? 50 by 3. 50 by 3 is how much? Quick. Very good. 16.666. If you have doubt, even small 1% doubt, don't hesitate to use the calculator. Okay. Right. Then this is not my record length. So I want the distance between calculation point and the centroid. This is the X bar, my X bar. What is this length? 100 minus 16.666 equal to how much? 83.333. Correct? Is it correct? Tell me the answer, please. Tell me the answer. See, this is not final answer. At last, we have to divide by EI. Right. Or if you are free, you can divide here itself. EI is given, right? EI. What is the EI value? 200 into Newton meter square, right? So Newton is okay. We want mm square. 10 power 6. 10 power 6. Okay. Directly you can tell. Tell me the final answer, please. After including EI, I think Abhay has given before EI, after. Okay, correct. Answer is correct. 0.26. 0.26 mm. Okay. Right. Correct answer. Very good. So I think now you are clear how to use the moment area method, right? Next question. So they have given a very big story. What is the essence of that story? Length of the beam is 3 meters, sir. Point A is located at 1 meter from the fixed end. Point B is located at 3 meter free end. Right, okay. When I am applying 20 kilonewton at B, what is the deflection at A? Tell me. Read the sentence and tell me. How much? 2 mm, sir. Correct? Right. Shall I say that Y A B equal to 2 mm? Correct? Yes. Right. Okay. Y A B. So this is for which load? Tell me. At P is equal to 20 kilonewton. Correct? Okay. 20 kilonewton. But in the final question, they are asking if I apply 100 kilonewton. Right. Okay. Now, second step. Suppose if P is equal to 10 kilonewton, 10 kilonewton at B. Right. Tell me, what is the deflection? What is the deflection? YAB, same YAB is equal to 1 mm, sir. Why? How do you say that? 1 mm. Sir, I know that deflection Y is equal to PL cube by 3EI. It means Y is directly proportional to P. Right? Y is directly proportional to P. That is why I said this answer. Now, from this, directly, can we say that YBA equal to 1 mm? Correct? Yes, right. This is valid when P is equal to 10 kilonewton at A. Right? Right. Okay, sir. Sir, what is the answer? Final answer? Final answer? 1 mm. 1 mm. Which theorem? Which theorem is used? This is which concept? Reciprocal theorem. Reciprocal theorem. Correct? Okay, done, sir. 2 mark for this. Next question. Sir, very simple question, sir. They are asking deflection at the free end, sir. What is the load? There is a couple at the midspan, sir. Draw the bending moment. Right? So this is L by 2. This is L by 2. Bending moment value 0. We will bring the EI at last, right? Otherwise, it will confuse, right? M, right? Then where is a calculation point? I want at the free end. This is a calculation point. Where is a zero deflection point? This is the zero deflection point. Y equal to 0, right? So what is the formula? Y is equal to A into X bar. What is the A? Area of M by A diagram between calculation point and Y is equal to 0 point. Right? This is the area, available area. Right? Sir, what is the area, sir? Equal to L by 2 into M. Right? Okay. Into X bar. What is X bar? Distance between centroid of the selected area and the calculation point. Tell me what is X bar? It is easy. 3 by 4 L. Right? So at last divided by EI. Tell me the answer. 3 by 8. 3 by 8 M L square by EI. Right? See, you have to check logically. In case of point load, deflection format will be WL cube by EI. This is fixed for point load, right? Then previous number may be some number. Sometimes 1 by 3, then 1 by 8, 5 by 384. That is different, right? So Y is directly proportional to 8. Then Y is directly proportional to UDL. If it is UDL, small w L power 4 by EI. Right? If it is couple, Y is proportional to M L square by EA. Right. So after substituting the given parameters, if you are not getting this format, you have to recheck it. Right? You have to recheck. Small mistake may be there. So for the small mistake, you need not worry or you need not get panic. Okay, because 2 marks will be lost. So this is a general format. Don't forget. So you are getting 3 by 8 ml square by EA. Check it. Is there any mistake? Correct? Okay, sir. Done. Next question. So Cast-Clear theorem, reciprocal theorem, direct formula, moment area method. Right. So Cast-Clear theorem, one more theorem we will go. Right. Go through this. Sir, first draw the BMD for the horizontal member, sir. Don't waste the time. Directly go to here. BMD for the horizontal member. Right. Where to draw? Here we will draw. Right. What is a maximum bending moment value? P into L. This is 0. This is 0. It is L. Right? Right. Okay. Then what is the bending moment for the vertical member? Sir, it is rectangle, sir. It is perfect rectangle. Right. This is 0. This is your M. What is a M? P into L. Correct? Any doubt? Any doubt so far? Vertical force. This vertical force is neglected, not considered for the vertical member. Right. Any doubt in the bending moment diagram? Any doubt in the bending moment diagram? Only yes or no? Any doubt? No doubt. Okay, sir. So one is varying bending moment, another one is constant bending moment. For varying bending moment, we have to write the bending moment equation, sir. For example, at this location, so this is at x distance. At x distance. What is this bending moment value? M is equal to P into x. Okay, done. Right. Okay. Sir, we will calculate separately. Sir, U1, strain energy due to varying bending moment in the horizontal member is equal to integration of m square dx by 2ei. Integration limit 0 to L. Right? Okay, let us complete this. So p square x square by 2ei into limit 0 to, sorry, integration not done. Right. 0 to L into dx. Integrate it p square by 2ei into x cube by 3. Right? X cube by 3. Limit 0 to L. Right? It means p square L cube by 6ei. Right? Check it. Is there any mistake? Right. For the vertical member U2, m square L by 2ei. Right? Right. Sir, what is MPL? So P square L square. What is the length? L, right? Divided by 2ei. It means P square L cube by 2EI. Total strain energy. Total strain energy. U is equal to U1 plus U2 equal to P square L cube by 6EI plus P square L cube by 2EI. Tell me what is answer? 4 4 by 6 4 by 6 2 by 3 right. 2 by 3 2 by 3 P square L cube by EA. This is total strain energy. What is the Castiglione theorem? Castiglione's theorem. Dou U total by dou Pi is equal to Y at I. Right? Okay. Now we are going to do partial derivation of P, right? With respect to P. So partial derivative. So 4 P L cube by 3 EI is equal to Y. Is it correct? Correct. 4 by 3, right? Yes. Okay. Next question. Can you do this question? Can you do this? Yes, moment area method. Correct. You can do it. Shall we do or you can do? Shall we do now? No answer. What is the bending moment diagram for this? BMD. Right. Very simple. Constant bending moment. 0. M. Means minus M. No problem. Okay. 0. M. Length L. Correct. Where is the calculation point? Calculation point. At the x equal to L by 2. This is the calculation point. Correct. This is y equal to 0. Right. So what about this distance? L by 2. L by 2. Correct. So flexible rigidity is EA. Be careful. Sometimes they may give 2 EA. Right? Okay. Now do it quick. Don't see the screen. Do it. Come on. Y is equal to A into X bar. equal to area L by 2 into M into L by 4 at last divided by A. Okay, right. What is the answer? M L square by theta. Done now, right? Okay, done, sir. Done. Okay, I think now you are very comfortable with the moment area method. Next, another little bit tough question. Read this question. So for linear elastic beam in the figure, flexural rigidity EA is given. W is 10 kilonewton per meter. Vertical reaction at A is 50 kilonewton. The value of reaction at A for W equal to 100 kilonewton. I think the first data, what is the first data? 10 kilonewton. So for we know deflection is directly proportional to small w. Correct? Right. At small w equal to 10 kilonewton per meter, y max equal to, we don't know, right? Or direct EA is given means directly we can go, right? Go for direct formula. Direct formula. Sir, what is asked finally? What is reaction at A is asked? Reaction at A is asked, right? Sir, what is a reaction at right end B first? That we don't know, right? Sir, what is the concept? Sir, according to the level of disturbance corresponding reaction will be developed, sir. Yesterday you told, if I am disturbing 100%, 100% reaction will be developed. If I am disturbing 70%, 70% reaction will be developed. Correct? Right. Sir, how much we are disturbing, sir? That we will do. Calculate, right? Deflection, downward deflection at UDL. Minus upward deflection at are due to reaction equal to gap. Correct? Equal to gap. Or we can write in the other way. Free downward deflection due to UDL. Free downward deflection due to UDL. It may be big number or small number. Okay, right. Minus gap equal to deflection due to reaction. Reaction at B. Okay, right. So we are writing the displacement equilibrium. Right. Sir, what is the modified one? Y UDL minus Y reaction equal to gap. This is for understanding purpose. Why are you writing this? Sir, what is the meaning of this? Anyone tell me what is the meaning of this? Meaning is very important. Sir, disturbed degrees of freedom, sir. Correct? This is the disturbed degrees of freedom. Disturbed deflection. Okay, right. This is telling that disturbed uh, deflection, right? Indication, right? Okay, sir. This is for calculation purpose. We are bringing the gap to the right side. UDL deflection format, small w L power 4 by 8 EI minus support reaction is RB. RB, right? RB is how much? Let us say RB equal to R. Okay, RB into L cube by 3 EI equal to gap is 0.006. Now substitute everything except RB. Everything is available in your hand. Okay, sir. Small w is how much, sir? 100. 100 kilonewton per meter, right? 100 into 10 power 3 into length 5 power 4 divided by 8 into EI is how much? 781250 into 10 power 3 minus RB into 5 cube divided by 3 into 781250 into 10 power 3 equal to 0.006. Now tell me what is RB. Calculate carefully. Tell me the RB value. Come on, quick. Very good. 75 into 10 power 3. 75 into 10 power 3. It is equal to 75 kilonewton. Very good. So what is the total load? RA plus RB equal to 100 into 5. Right? Right. So RA equal to 500 minus 75 equal to 425 kilonewton. Right? Okay. Sir, this is one method, sir. This is one method. Correct? Right. Answer is ready. 425. Sir, another method. You can think in the other way also. Okay. Right. How, sir? Right. Sir, first I am calculating the free deflection, sir. Free deflection. Right. First I am calculating free deflection. Be ready for calculation. M2. Y UDL free equal to small w L power 4 by 8 EI. Because some students are having doubt in their mind. Okay, they did not ask, but I know. Calculate this. 100 into 10 power 3 into L. L is 5. 5 power 4 by 8 into 78125 0 into 10 power 3. Tell me what is the answer? How much you are getting? Sir, 10 mm, sir. This is equal to 0.010 meter equal to 10 mm, right? Sir, what is the gap? Gap, sir. Y free is greater than gap. It means partially disturbed. Partially disturbed. Correct? Right. Sir, if it is partially disturbed, what is a disturbed deflection? Y disturbed is equal to 10 minus 6 equal to 4 mm. Right? So this is equal to RB L cube by 3I. Correct? Correct? Right? So disturbed deflection is assumed as deflection due to RB. Right? Okay. Now substitute. Tell me 0.004 equal to RB into 5 cube by 3 into 781250, right, into 10 power 3 equal to this gives RB equal to 75 into 10 power 3 Newton. That is RB equal to 75 kilonewton. Correct? Is it correct? Yes, sir. Then automatically RA equal to 500 minus 75 equal to 425 kilonewton. This is another method. In this way, another model is asked in the strength of material. Do you remember which question? The same method. Disturbed del L. This is for disturbed deflection. For disturbed del L, another model is asked. Anyone? Thermal, sir. Excellent, excellent. Thermal. Right? So I will show you. Okay. Do you remember this question? Yes. First we have to find out the del L free. Then we have to check with the gap, right? If the del L free is greater than gap, then we can say it is disturbed. Right? Then calculate the disturbed del L, calculate the corresponding strain, calculate the corresponding stress. Right? Right. Yes. Right. Very good. Next question. Read this question. So simply supported beam with the central point load, normal case. Right? Then there is a spring, central spring. Right? So the central deflection of the beam due to concentrated load. If there is no spring, okay, easily you can give the answer, right? Right. But there is a spring also. How to calculate? Any idea? Spring force. Sir, what is a spring force, sir? What is a spring force? Stiffness is equal to force by deflection. Correct? Then this is equal to reaction by deflection. Here in this case, reaction we can say, right? Then R is equal to K into delta for the spring. Correct? Right. Resistance. Resisting force, right? What is the resistance for the deflection? Sir, we have the formula, sir. WLK by 48 EA, sir. From that, we can calculate the resistance rate. So, displacement equation is easy to write. Displacement equation, right? Right. Simply draw the diagram. Right. This is the load. This is the load. Reaction. This is the applied load P. This is the reaction R. Right. Right. Reaction R. Now, deflection Y, maximum deflection, is equal to deflection due to downward deflection due to P is how much? P L cube by 48 EA, correct? 48 EA minus deflection due to this load. What is the deflection due to reaction? Delta. Delta is equal to R by K, right? R by K, correct? Delta is equal to R by K. Separated, right? So what is the net deflection? You can say these are individual deflections. This is equal to or this one, first one. Another color. equal to P minus R L cube by 48 EA. Correct? Is it correct? Yes, sir. Yes, right. Now imagine. Now imagine what we can do. They are asking delta only. Idea, quick, simplify, very simple, right? We want separate R, this R. If you calculate the R, we can find the deflection. Sir, group it, sir. Group. Bring both the R right, together. R by K. R by K. I'll use another color. R by K plus R L cube by 48 EA equal to P L cube by 48 EA. Correct? Right? Or for simple understanding, let us assume this capital W. Actually, W is not applied actual load, right? You can assume this thing. Sir, what is this W, sir? This is general format. What is this W? Tell me. W is equal to P minus R. Okay, right. Now you can understand easily, right? Okay, right. Now tell me, just grouping, rearrangement only. Next, what to do? Bring the R separately. R into 1 by K plus L cube by 48 EI equal to PL cube by 48 EA. Okay, done. Now cross multiply this. Only K is common, right? So R into 48 EI plus KL cube by 48 EIK equal to PL cube by 48 EA. Okay, right. Now what is R? R is equal to what are the things we can cancel? 48 EA, yeah. 48 EA cancel. Okay, right. Okay. Now see the remaining things. R is equal to K PL cube into K by 48 EI plus KL cube. So this is our R, right? So once you know the R, we can find the deflection, right? So deflection of spring equal to R by K. equal to R is known. If you divide by K, what is that? PL cube by 48 EI plus KL cube. Correct? Right. Which option is matching? Option A. Wow. Okay. Right. One more question. I will show. You can solve in the home. Take the screenshot. Take the screenshot. Done now. Done. Take screenshot. Okay. Next question. Take the screenshot. Done. Right. Take the screenshot. You don't say it is not asked in mechanical engineering. Maybe asked in mechanical or civil or PE somewhere, but it is asked question. Okay. Okay. Wow. Taken. Next question. Very, very interesting question. Take the screenshot. So tomorrow come prepared with the more circle principal stress calculations, whatever we discussed in the classroom. Okay. Directly we can go to questions tomorrow. More circle principal stress calculations. If possible, theory of failure also. Right? Don't forget. We cannot discuss in the class. Only questions we want to discuss tomorrow. Right? Take, screenshots taken up? Okay, done. Take the screenshot. Okay, done. Next. Take the screenshot. Taken. Yes, okay. Take the screenshot. Okay. Take the screenshot. Okay. Next. This is rare case. UVL rare case. Anyway, take the screenshot. Okay. So try to solve everything. Try to solve everything. Nobody is going to check you. Okay. It is a self-discipline only, right? If you want to mark, if you want good practice, you solve all the questions. Okay. If you have any doubt, we can discuss. Right? Okay. Okay. So thank you so much. We will discuss in the tomorrow's class. Right? So deflection means what? Direct formulas are moment area methods are Castigliano theorem, strain energy method, then reciprocal theorem. Right? So these are the main focus in the deflection and slope point of view. Okay, sir. Thank you. Thank you so much.